let's look at the key for your sample quiz for 3.7 and 4.1. So you'll notice that you will not be using a graphing or a scientific calculator. You'll be using one of the 4-function ones that we have in our classroom. So just keep that in mind while you're working on these. All right, so first they asked me to find the inverse of a function. So to do that, step number 1, we switch x and y, and then number 2, we solve for y. So when I'm looking at my function, remember that g of x is y. So I've got y is equal to 8x minus 7. I'm going to switch x and y, so that would be x is equal to 8y minus 7, and we can see that right here. All right, now step number 2, solve for y. So to get y by itself, I'm going to add the 7 to both sides, and then I'm going to divide both sides by 8, and so this would be my inverse function. All right, then for the second one, same idea. I'm going to first switch x and y. So x is going to go on the left-hand side, and it'll be 3 times y instead of 3 times x. All right, and then I want to get y by itself. So let's multiply both sides by 6. So that gives me 6x on the left, and then the 6 cancels out on the right-hand side. Now to get y by itself, add 4 to both sides, and then divide by 3, and that would be my inverse function. All right, for number 2, they ask us to use the composition of f of x and g of x to determine if those two functions are inverses or not. So if f of x and g of x are inverses of each other, when you do the composition f of g of x and g of f of x, they'll undo each other and they'll just leave you with x. So when you do that composition, if you get anything other than x both ways, then they are not inverses of each other. So to do f of g of x, first off, let's replace g of x with what it's equal to. So it's equal to this fraction. So we're going to have f of that fraction. All right, so that means in the f function, we're supposed to put that fraction in the place of x. So it's going to be 3 times the fraction minus 2. So right here, 3 times the fraction minus 2. You can see that the 3 in the denominator and the 3 are going to simplify, so that would just leave me with x plus 2 minus 2. And the positive 2 and the negative 2 eliminate, and that leaves me with just x, which is what I was hoping to get. All right, then let's do g of f of x. So if we come up here, f of x is 3x minus 2. So let's replace f of x with 3x minus 2, and we're putting that into the g function. So now we're going to put 3x minus 2 right there. So that'd be 3x minus 2 plus 2 divided by 3. So 3x minus 2 plus 2 divided by 3. So the positive 2 and the negative 2 are opposites and cancel each other out. That leaves me with 3x over x, and the 3's cancel each other out, and again, I'm left with just x, which was what I wanted. So again, if you do f of g of x and g of f of x, and you get x both times, then they are inverses of each other. All right, then for number 3, they ask us to use a table or a graph to determine if the two functions are inverses of each other. So remember that when we solved for the inverse just a moment ago, we switched x and y, right? So the way you can look at a table and see if they're inverses is if you have the point 5, 0, x and y have to switch places and be 0, 5. 3, 1 has to swap to be 1, 3. 1, 2 swaps to be 2, 1, and negative 1, 3 swaps to be 3, negative 1. So for every x, y in f of x, there was a yx for g of x. So yes, those are inverses. All right, skip down here to D for just a second. All right, so again, if I have the 0.50, then over here I would have to have the 0.05, and I don't. I don't have it anywhere in my table. So what they've done is they've inverted the table, like we've got 50 here and 50 here, and we've got negative 13 here and negative 13 here. They flipped the table, they didn't flip x and y. So for every x, y in f of x, there is not a yx for g of x. So the points are, so no, it is not going to be an inverse because literally these points are all the same in both tables. They're just in different orders. Okay, let's look at a graph. So if we're looking at a graph, two things must be true. First off, the inverse is going to reflect in the line y equals x. So what we mean by that is y equals x is one of our toolkit functions. It's diagonal line right here. All right, so that means that if I drew my original function in wet paint, and then I folded my piece of paper on this dotted line right here, that wet paint would transfer over to be the inverse. And so I can look and see if I fold my piece of paper right here, is that graph going to fold on top of itself? Yes. The other thing I can check is, again, I could pull some points off of my original function. So I've got like -4, 0, 1, 2, and 5, 4. So if I have -4, 0 on the original, that has to be 0, -4 on the inverse. If I have 1, 2 on the original, that has to be 2, 1 on the inverse. If I have 4, 5 on the original, that has to be 5, 4 on the inverse. So every xy on one line is yx on the other line. So yes, those are inverses. If I come over here and I look at this one, neither one of those things are true. If I draw that line y equals x and I fold my piece of paper on that line, that graph is not going to fold on top of itself, so it doesn't reflect in that line. Also, if I pick a point off of one of the lines like 0, -3, that means that on the inverse there would have to be a point -3, 0, and if you'll notice that -3, 0, that point is not on this line. So this line is not the inverse of this line. All right, then for number 4, they asked me if h of 8 is equal to -3, then what's the inverse of -3? So remember, this is our notation for inverse right here, this h to the -1. So if I have the ordered pair 8, -3 for the original, then for the inverse, x and y switch places, that would be the point -3, 8. So when I plug -3 into that inverse, I'm going to get 8. All right, then for number 5, it says use this graph over here to the right. And they ask us to find, first off, f of -1. So we're going to come over here to where x is -1. And we're going to go up and see our y value is +2. So that would be the point -1, 2. So f of -1 is 2. Then they asked me to find the inverse at 2. Okay, so if I have the point -1, 2, the inverse point would be 2, -1. So that's saying when I plug 2 into the inverse, what do I get? Well, I get -1. For this next one, they didn't give me the starting point. They just asked me to find the inverse point. Okay, so I'm looking for an inverse of 1. All right, so I can come over here and I can see my y value is 1 right there at the point 0, 1. So if the original function was 0, 1, then the inverse point would be 1, 0. So the inverse of 1 would be 0. We can do the exact same thing from a table. So here's our table, and they asked us to find f of 2. So if we come over here, when x is equal to 2, f is 4. So that would be the point 2, 4. So the inverse point would be 4, 2. So when they say what's the inverse at 4, then that would just be 2. All right, and then for this next one, they asked me for the inverse of 5. All right, so if I come over here, you'll notice I have the point 4, 5 on the original. That would be the point 5, 4 on the inverse. So when I plug 5 into the inverse, I get 4. All right, then for number 7, they asked me to tell whether I have a function, a one-to-one function, or neither. So remember, to tell if something is a function, you're going to do a vertical line test. So that means I'm going to draw a vertical line and make sure that I don't hit my graph in more than one spot. So when I draw vertical lines on this, I do not hit my graph in more than one spot. So yes, that is a function. Then to see if it's a one-to-one function, I'm going to do the horizontal line test. I'm going to draw horizontal lines and make sure I don't hit my graph in more than one spot, and I don't. So this passes both the horizontal and the vertical line test. So therefore, it is one-to-one. So I would say, okay, that first graph meets the qualification of Roman numeral number 2. All right, then look at this next one. All right, so for this next one, does it pass the vertical line test? Yes, I can draw vertical lines and not hit it in more than one spot. So yes, it is a function. Does it also pass the horizontal line test? No. So that means that its inverse is not a function. So it's a function, it's just not a one-to-one function. So that would be our first Roman numeral up here. And then this last one, when I draw a vertical line, I do hit the graph in more than one spot. That means it fails the vertical line test, so that means it's not a function at all. There's no need to check the horizontal line test because the only thing the horizontal line test tells me is if it's a one-to-one function. If I already know it's not a function, it can't be a one-to-one function. So we would just say that one's not a function at all. So that would be the condition of Roman numeral number 3. All right, then that was section 3.7. Then we moved into section 4.1, which was a review of section 2.2 and all of our things about slope and graphing lines. So to begin with, they gave me 2 points and they asked me to find the slope. So I know my slope is going to be y2 minus y1 over x2 minus x1. So I'm going to label this x for 0.1, y for 0.1, x for 0.2, y for 0.2. So I can do y2 minus y1, 3 minus a negative 7, over x2 minus x1, negative 5 minus 2. So that's going to give me 7 plus 3, which is 10, and negative 5 minus 2 is negative 7. So I'll get negative 10 sevenths for my slope. All right, and then for number 9, they told us that we had a slope of negative 2, and we had the point 4 negative 2, and they wanted us to give the equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So we know that our slope negative 2 is m, so let's put negative 2 in for m. And then we'll put 4 in for x and negative 2 in for y. So 4 in for x and then negative 2 in for this y. So 4 times negative 2 is going to give us negative 8. So let's add 8 to both sides and we'll get b is equal to 6. So now to write our equation, y equals m, the slope was negative 2, x plus, we just found b was 6. So our answer would be y equals negative 2x plus 6. All right, then for number 10, they ask us to write the equation of the line in standard form. So that's the ax plus by is equal to c. And they only gave me 2 points this time. Okay, so if they give me 2 points, the first thing I need is a slope. So I'm going to do what we did a moment ago. I'm going to do y2 minus y1 over x2 minus x1 to get my slope. So I'm going to do 7 minus negative 3 over negative 1 minus 4. So 7 plus 3 is 10. Negative 1 and negative 4 is negative 5. So that gives me a slope of negative 2. Now, you can choose either one of these points that you want to. I picked the first one, but you could have picked either one. So I'm going to take y equals mx plus b, and we just found it. M was negative 2, so let's plug that in. And we said we were going to use the 0.4 negative 3, so x would be 4 and y would be negative 3. And now we can solve for b. So negative 2 times 4 is negative 8. Let's add 8 to both sides, and we'll get positive 5 for our b value. So now if we write our equation, it's y equals m. We found m was negative 2. X plus b, we found b was 5. Now, if they told me to give my answer in slope-intercept form, that would be my answer. But they asked me to give it in standard form. So in standard form, all I need to do is just add this 2x over to the other side because it needs to be ax plus by is equal to c. In standard form, x and y are on the left and the constant is on the right, and you also have no fractions or decimals in your answer. It has to be whole numbers. All right, then for each of the following, they ask us to find the slope and the y-intercept and to sketch the graph. So again, remember that this is y equals mx plus b, so we can just look at it and see m is 1/2 and b is negative 4. So to graph that, we start at our y-intercept of negative 4, and then our slope of 1/2 is our rise over run. So we're going to rise a positive 1, run a positive 2. Rise a positive 1, run a positive 2. Now, 1/2 could also be negative 1 over negative 2. So again, if you start at this point and rise a negative 1 and run a negative 2, you're going to have a point on that same line. All right, look at the next one. So for the next one, you can see our slope is negative 2/3, and then there's nothing over here being added for b. That just means b is 0. So we're going to start at 0 for our y-intercept, and then from there, we're going to rise negative 2/3. Now, you could rise a positive 2, run a negative 3, or you could rise a negative 2, run a positive 3. Both of those would be points on that same line. All right, then for C, we've got y is equal to negative 3. So every horizontal line on the face of the earth is going to have the equation y equals something. So we know that this is a horizontal line. And every horizontal line has a slope of 0. You also can see that where this is crossing the y-axis is at negative 3, so that's going to be our y-intercept. For the last one, x equals 1, every vertical line on the face of the earth has the equation x equals something. And remember, you can't ski this. This is not a slope, so that's no slope or undefined slope. And there was nowhere across the y-axis, so